In this next lesson, we will take a look at how the unit circle and quadrants can be used to solve trigonometric expressions such as sine of x equals a half for values of x between 0 and 360 degrees, sine theta equals 1 over root 2 for all real values of theta, and for cos 3 theta equals a half for both cases where theta is a real number and also for the case where theta is between 0 and 2 pi. Okay, in this question, we're asked to plot the graph of sine x between 0 and 360 degrees. So what we do is we lay out suitable increments of x. Here I've selected increments of 45 degrees between 0 and 360, and we get the corresponding sine values. And as you can see, the maximum value is 1. The sine of 45 is 0.7, and the 135 is also 0.7. So if we do a layout here with increments of 45 along the x-axis and a 0.5 along the y-axis, and put in the values of sine corresponding to each of the values of x, we get the following curve. So this is the typical sine of x graph. The range, the maximum value is between +1, the maximum value is +1, the minimum value is -1, so the range is between +1 and -1, and you can see that the graph starts to repeat itself every 360 degrees or every 2 pi. In this next question, we're asked for what values between 0 and 360 degrees is sine of x equal to a half. Okay, so we're asked to get the values between 0 and 360 degrees. So this is the sine wave that we had earlier on, or the sine graph, and we could, if we were to draw a line along through 0.5, this is the line y equals 0.5, we could see that the value of x is somewhere around here, around the 30 mark. So sine of 30 roughly is about 0.5, and there's another value up here somewhere. As we'll see, it's about 150 degrees. So the way we do these questions, first of all, we ignore the sine of a half and we calculate the reference angle. So if we say sine of x equals a half, then inverse sine of a half is equal to x, which is 30 degrees. So the reference angle is 30 degrees. So next we work out in which quadrants is sine positive. So we can see it from the graph here. Between 0 and 90, sine is positive. Between 90 and 180, the second quadrant, sine is positive. And between 100 and 227, sine is negative. And between 270 and 360, sine is also negative. So the two quadrants are the first and the second. So what we do is we put the reference angle into each of these two quadrants. So there's 30 degrees in the first quadrant, and there's 30 degrees in the second quadrant. So we always measure the angles from the positive sense of the x-axis. So if you take 30 from 180, we get 150. So this angle here can be defined as 150 degrees. So sine of 150 will give us a half, and sine of 30 will also give us a half. So therefore we can write x, the two values of x that will, when we get the sine of these values, will give us a half, is 30 and 150 degrees. And if we were to look at the graph of sine x again, we could see that when x equals 30 degrees, the sine of 30 is a half, and when x equals 150, the sine of 150 is also equal to a half. So there are two values of x between 0 and 360 that when we get the sine of those values will give us a half. In this next question, we're asked to solve the equation sine of theta equals 1 over root 2 for theta an element of r, where theta is in degrees. So once we see this expression, theta an element of r, this really means there's an infinite number of solutions, or we call this the general solution. So as before, the first thing we do is get the reference angle. So again, we can say that if sine theta equals 1 over root 2, then theta is equal to inverse sine of 1 over root 2, which is 45 degrees. So the reference angle is 45 degrees. Again, we check to see which quadrants is sine positive in, which is the first and the second, between 0 and 90 and 90 and 180. So we can do a rough diagram and put in the reference angle in the first quadrant and the reference angle in the second quadrant. And as before, we measure the angles between from the positive x direction, or positive sense of the x-axis. So 180 minus 45 is 135. So we can say that when theta is 45 degrees and when theta is 135 degrees, the sine of these two values will be 1 over root 2. So let's consider the first value here. When theta is 45 degrees, the sine of 45 is 1 over root 2. But if we were to add 360 degrees onto 45 degrees, we'd move one complete revolution. So we're back to the same position. So adding multiple times 360, or n times 360, where n is an integer, will give us the same solution. So the general solution for 45 degrees is 45 degrees plus n times 360. Similarly, for the second solution, when x is equal to 135, sine of 135 is 1 over root 2. And again, if we were to add multiples of 360, where n is an integer, we'd get back to the same position here. So we could write when theta is equal to 135 degrees plus again n times 360. And remember, we need to write n is an element of, or n is an integer. In this last question in this video, we're asked to solve the equation for cos of 3 theta equal to a half. For two possible conditions, one where theta is an element of r, and the other where theta is between 2 pi and 0. Now for the first question here, if theta is an element of r, we really ask for the general solution. And once again, we get the reference angle, so we let cos 3 theta equal to a half, which means that 3 theta is the inverse cos of a half, which is pi over 3, or 60 degrees. So if we look at the quadrants where cosine is positive in the first and the last quadrant. So we can say, we can do a rough diagram, and we put 60 degrees, or pi over 3, into each of these quadrants. So there's the first quadrant, there's pi over 3, and in the last quadrant, there's the reference angle for pi over 3. So as before, we always measure the angle with regard to the positive sense of the x-axis. So this angle here is 360 minus 60, or 2 pi minus pi over 3. 2 pi is 6 pi over 3. So if you take pi over 3 from 6 pi over 3, you get 5 pi over 3, which is 200 degrees. So we have the two angles now. We can say when 3 theta is equal to pi over 3, cos of pi over 3 is going to be a half. And when theta is equal to 5 pi over 3, cos of 3 times 5 pi over 3 will also be a half. So we could write the general solution. So we could say the general solution is for pi over 3 will be when 3 theta is equal to pi over 3 plus again multiple times of 360, n times 360, or n times 2 pi. And we can also say when 3 theta is equal to 5 pi over 3, or multiple times 2 pi again, n times 2 pi, where n is an integer, will give us cos 3 theta equal to a half. So remember, we're actually looking, when it says solve the equation, we're looking for theta, not 3 theta. So theta is going to be pi over 9 plus n, 2n pi over 3, or theta is equal to 5 pi over 3 times 3, 5 pi over 9 plus 2n pi over 3. And if you want, you can get the common denominator here, which is 9. So 9 into that goes 1 times, so you've got pi. 3 into 9 goes 3, 3 2s are 6. So when theta is equal to pi plus 6n pi, or again taking the common denominator here, we get 5 pi plus 6n pi over 9. And once again, we must specify that n is an integer. So this represents all the solutions of theta, all the values of theta, that when you multiply by 3, you will, and you take the cosine of it, of these angles, you'll get a half. In part 2 of this question, again we're asked to solve 3 theta equal a half, but this time for theta between 0 and 2 pi. So here we have the two general solutions. These are all the values of theta that will give us a half when we take the cosine of it, where we take the cosine of 3 times these values. So all we do here is we go through the values of n in integers. So, for example, when n is 0, we're going to get theta equals pi over 9. When n is 1, we're going to get 6 pi plus pi over 9, which is 7 pi over 9. And when n is 2, we'll get 12 pi plus pi over 9, which is 13 pi over 9. And if we were to go again, if we were to say n equals 3, we get 18 pi plus pi over 9, which is 19 pi over 9. And 9 into 19 pi is going to be greater than 2 pi. So we ignore the values of theta for when n is 3. And over here, we can say when theta is 0, theta is equal to 5 pi over 9. When theta is 1, we get 6 pi and 5 pi, 11 pi over 9. And when n is 2, we get 12 pi and 5 pi is 17 pi over 9. And again, if n is 3, you're going to get 15 pi plus 5 pi, which is 20 pi over 9, which again is greater than 2 pi, so we ignore these values. So all the range of values for which theta is, for the value of 3 times theta is equal to a half, is going to be 7 pi over 9, 13 pi over 9, 7 pi over 9, pi over 9, 13 pi over 9, and these values here, 5 pi over 9, 11 pi over 9, and 17 pi over 9.